can do it the old-fashioned way. We don't need any slides.
No, no, no, of course not.
Okay.
What, I don't know what is the matter.
Okay, I will share the screen, I think.
Can you share? Yeah.
Yes, yes.
Hocam siz kendi şeyinizi kapatın. Açamaz yoksa.
Hoca kendi sayfasını paylaşacak. Ben hak edemedim bunu. Ne oldu bilmiyorum.
Şu anda başlıyor hocam.
This will stop other screen sharing. Do you want to continue?
Opa, pardon.
I think it's okay. It seems okay now. Yeah.
Okay, excellent.
Yeah. Here you are.
Thank you very much.
You can start now. I am sorry for the delay and for the
no problem. My name is Natalia Haralabidou. I'm teaching at the Faculty of Law of Democritus University of Thrace. I was very anxious because I'm coming from law. I don't have anything to do with technology. And I was, oh my God, we are going to do this live. So we also have to take care of the setting and the technology. And I was extremely anxious. So thank you very much.
You are very good in this technology. I see you. Thank you very much.
Thank you. So let me talk to you about carbon capture and storage, the policies behind it, not the technology itself. The technology is something that the real scientists have to do, not we coming from the from law. So the main question which triggered my interest into looking into this subject was the fact that the renewables, energy efficiency, and carbon capture and storage were introduced at the same time, simultaneously, with the same papers. So the world leaders were discussing these three technologies at the same time. But now we see that renewables and energy efficiency are the mainstream. We hear and we read about these technologies a lot, every day, but we do not know so many things about carbon capture and storage. And it made me very curious. Why has this thing happened? And let's see first what is carbon capture and storage. Because it's exactly a technology thing, I believe it's better to describe it, not define it, because if you define it, you attach a definition and technology evolves. So this definition will not be able to follow the development of the technology. So one description that I found, it says that the CCS involves the use of technology, first to collect and concentrate the CO2 produced in industrial and energy-related sources, transport it to a suitable storage location, and then store it away from the atmosphere for a long period of time. And I like this description because it illustrates the four stages that are related to carbon capture and storage. First, collect and concentrate. Second, transport. Third, storage. And most importantly, is to measure, monitor, and verify that the CO2 is really stored under the earth. The EU has adopted another approach. The EU has chose to define CCS, and it names CCS as geological storage of CO2, and it has attached to it a definition. The injection accompanied by storage of CO2 streams in underground geological formations. So it only has the injection and the storage. It doesn't have the temporal element that the storage involves storage for a long period of time, and also the transport is absent. And I believe now that I say it, there is another element that is absent, that of capture. It just goes directly into the injection. And there are two final notes with relation to the description of CCS. The first one is that captured CO2 can be stored in land, and this is called sometimes onshore or geological. and in the seabed, and this is called sometimes offshore or ocean, but we don't have to be very specific on these matters because terminology has not been yet settled. And also, as the technology has evolved, CO2 can now be captured direct from the atmosphere and not only within energy and industry. And now we can go to the turning point. I believe that the year 2005 was the turning point for the CCS for two reasons. First of all, the leaders of the G8 countries noted that CCS is an essential tool for the decarbonization of energy, along with renewables and nuclear, and asked the International Energy Agency to provide support in the sense of reporting on what needs to be done. What are the obstacles, what is the technology involved, who has done that before and knows what can be done. And the second point is that the IPCC produced a fundamental report on CCS. So for these reasons, I believe that 2005 was the turning point. And now we can see what happened before 2005 and what has happened since 2005, what has happened in the last 15 years. And first, let's go to the past. Before 2005, CCS was not unknown. There was the first large-scale project initiated in 1996 in Norway, the Sleipner project, capturing CO2 from natural gas processing. And there have been, even before that, since 1972, CCS projects for enhanced oil recovery operating in the US in the industries of natural gas processing and fertilizers. And also there was another big milestone. In 2004, the Insalak project in Algeria was initiated. So CCS was operating, it was not just tested, it was put into action before 2005. And this is important because as you get the natural gas out from wherever it is stored naturally, you get the CO2. So it's an excellent solution. Before the CO2 is released into the air, you can capture it and store it. So there will not be adverse effects onto the environment and climate change and etc. However, before 2005, despite the said projects, what we have already explained before, carbon capture was associated with nature-based solutions in the sense of planting more trees or, planting more trees, which is of course acceptable, but with the damage that has been done is not very effective. And also in December 2006, the UN has established a group. This is also important because this group wanted to facilitate experts both from the government and the industries in order for them to exchange information and experience on this matter. And it's important to have both the corporations and the industry and the governments to talk about these things, how they can put it into action. And also in December 2006, the UN recognized CCS as a promising technology for clean coal. So these were the first steps after 2005. There have been some concerns regarding the incompatibility of ocean storage of CO2 with international maritime instruments. There was the London Protocol and the OSPAR Convention, but these concerns were eliminated because there have been, these instruments were appropriately amended, and there is no obstacle with regard to storing CO2 in the seabed or transporting CO2 for the purpose of storing it. What is also important, because CCS has developed as a technology, is that CCS is not more just a coal technology. It can be applied to a variety of industries. It can be applied in the steel industry, in the cement industry, in chemicals and fertilizers. It can also be applied to energy, refining, natural gas processing, gas-fired power, coal-fired power, CCS with bioenergy, and enhanced oil recovery. And it's a very important development because in this manner, these industries will be able to deliver products with low carbon footprint if there is a market for it, and we can create the market for it, as we will discuss a bit later. Furthermore, since 2005, it has been established that CCS is essential for deep emission reductions. It is crucial for negative emissions, and it's fundamental for energy security, and it ensures energy diversity. And also the energy ministers of the G20 countries committed to support research, development, and deployment of CCS. And let me share a brief note with regard to energy security. Why I mention this? I mention this because today we have the infrastructure of producing electricity from coal and from other minerals, and this is not good for the environment. We know that, but we have the infrastructure already there, and we need energy. One smart thing to do would be to remodel this infrastructure with this technology, the CCS technology, in order to get green energy, alongside using renewables and energy efficiency. I don't believe it could be very realistic to just scrap off all this infrastructure. That's why I mentioned energy security. And let's go to the next one. The International Energy Agency had recommended the deployment of 100 large-scale CCS projects by 2020. But unfortunately, we have now 2020, and there are only 21 projects operating. And we are off track. This is not enough. And also one more important thing is the storage, and we have to map the CO2 storage potential. This is still something that is not done very widely. And now one can think, why is this the picture now? What has created the obstacles for the deployment of CCS? I believe that two are the main obstacles. The first one is the high costs of CCS. And why does it have high costs? It has high costs because unlike energy efficiency and renewables, it does not generate revenues. I mean, you have to buy products that have low energy efficiency. You have to live in buildings that have low energy, high, so apologies, energy efficiency. And you still have to use renewables, but you are going to buy the renewables and you are going to buy these products. With CCS, this does not happen. And one more important paragon is the effective community engagement. One example, big example, is what happened or has not happened in the Netherlands. Shell intended to make such a project in Barendrecht, if I pronounce this correctly, in the Netherlands, but this project was cancelled because of strong opposition from the local community and the local government. The local community and the local government didn't understand the technology, and there is always this fear that somehow CO2 is going to escape from the storage and it's going to go back in the atmosphere, and God knows what will happen. And all this uncertainty caused the whole project not to be made at the end of the day. So now that we have seen the obstacles, maybe we can see what can be done in order to deploy CCS. And I believe I came up with some suggestions, which are also suggestions of the International Energy Agency. They are not mine, for God's sake, no. The first one would be, and it's undeniably a very important one, is strong governmental support through policies. These options can be tax credits, grant funding, feed-in tariffs, and CCS obligations and certificates. And also important would be to encourage a market for low carbon materials, such as steel and cement, through private and public procurement rules. I mean, for example, when a government is going to make a project and is going to receive the tenders for this project, and in the rules of the public procurement, they say we want to have cement, for example, with low carbon footprint, this will push the industry to make such products. The second suggestion is public engagement. And this is what we can learn from the Shell's failed project in the Netherlands. If the people who wanted to make this, and by the people I mean both the industry and the government, can communicate to the local population and the overall population, and explain the technology behind it, why this is necessary and why this is extremely good for the whole of humanity, not just the local place, then I believe this will push the adoption of these policies. Also, I believe this could be great, is to establish a commercial market for captured CO2. I mean, if the scientists can find a way of what can we do with this CO2, how can we use it, how can we make it into a product, then there will be a product for the CO2 that is captured, will help this technology to be deployed. And of course, support of private investments is very important because the CCS has a large cost behind it. It can take up to 10 years from its discussion to its actual deployment. So private sector is very important because the public sector cannot handle this by itself, no way. And in order to encourage the private sector the private investments to participate, it is important to have a long-term target and policy flexibility in order to ensure investor confidence. Investors want to go to places where the policy is stable. Of course, there must be some balance between a stable policy and some flexibility in order to allow the policy to adapt to new information and to new developments in the technology. But it is important for the stability of the regulatory scheme for the investors to come and invest their money. So the conclusions, the deployment of large-scale CCS projects is crucial for the clean energy transition. Renewables, energy efficiency, and nuclear power by themselves are not enough. There have been already many lessons learned from the Sleipner project in Norway and the Insalak project in Algeria. Policy support is crucial. Governments have to step up and support this technology. Public engagement is decisive because the local population, the local governments can actually stop sometimes such a project and other projects. Encourage private investments is indispensable. Stability of the public policy will attract investors, and create a market for captured CO2 can be the game changer. And this is something that can be done by the scientists themselves. So that was from me. Thank you very much. I believe now there might be some time for questions.
Thank you very much for your informative presentations. Any questions? May I ask you a question, please?
Of course, yes.
Yeah. This technology seems cheaper than all the others, maybe in the future. Is it? Not at the moment, but in the future.
Actually, this is a very interesting question because I read somewhere, and this was not a very recent paper, that the captured CO2 per ton is cheaper than the penalty that the industry has to pay, where there's this greenhouse gas trading platform. So I believe that it is already cheaper. And if we approach this question from the viewpoint that I have said before, from the viewpoint of the energy security, you have the power plant, the coal power plant that is already operating. Mm-hmm. So you just put the CCS technology there, you get clean energy. I believe this is much cheaper than building a new nuclear power plant or creating a new solar farm or wind farm or whatever. So it is also a matter of perspective. And thank you very much for this question.
Thank you very much.
Thank you
for your answer. Natalia, could you please give the host to Istanbul Hall, please?
No. Hocam Natalya değil. Herhalde
değil mi?
Luyendamila, Professor Luyendamila.
Oh, okay.
Please. Please give me.
Ludmila, dear Ludmila, could you please give back the host position to Istanbul Hall, please? We have problem in hosting. Ludmila, are you there? Ludmila? Ludmila, are you there? Ludmila, can you hear me? Ludmila?
Hocam şu anda host oldunuz. Hocam hostluk sizde kalabilir hocam. Siz Ludmila girdikten sonra bana söyleyin, ben hemen görüntüsünü paylaşabilirim.
Tamam, şu anda yok Ludmila.
Gelecektir hocam. Hocam
evet, herhalde
kabul
gelecektir.
Edin.
Evet. Bekleyeyim mi yoksa devam edeyim mi?
Takdir sizin sayın hocam.
Ludmila, are you there? Can you hear me? Ludmila, are you there? I cannot see Ludmila. So, shall we carry on with third speaker, Erdem Çiftçi? Erdem Çiftçi? I think he's not here at the moment.
Hocam davet bekleyen varsa alın diye yazıyor.
Yok, şu anda yok bekleyen.
Sayın hocam, ben Erdem Çiftçi'ninkini yayınlıyorum.
Peki, tamam. Teşekkürler.
Ludmila geldiği zaman alırız.
Tamam.
Ben yayınlıyorum Erdem Bey'inkini.
We are now listening Erdem Çiftçi's presentation.
First of all, I would like to welcome to International Conference on Advanced Material Science and Engineering and High Technology Device Applications. My name is Erdem Çiftçi. I'm from Turkey and I'm a research assistant at Energy Systems Engineering of the Gazi.
Geliyor, evet.
I'm planning to present our study titled Influences of Single-Type and Hybrid-Type Nanofluids on Heat Transfer Characteristics of Plate and Concentric Tube Heat Exchangers, in which the effects of unitary and hybrid nanoparticle utilization in nanofluid preparation on thermal characteristics of the plate and concentric tube heat exchangers were investigated. My presentation content will be as shown. At first, I will give some information about unitary and hybrid nanofluids and utilized material and methods. After that, I will tell our experimental studies. And finally, I'm going to mention about the findings obtained from the tests. Nanoparticles containing fluids have become the working fluids of nowadays thermal systems. Some improved characteristics, such as high thermal conductivity, are the reasons for the preference of them. So, for the nanofluid utilization in thermal systems, especially in various heat exchangers, has been studied by many investigators. Because of some thermophysical properties, metals and metal oxides are the main materials used in nanofluid preparation. However, the problem is that metal oxides deteriorate the stability of the suspension, and compared to metal oxides, metals have low thermal conductivity. To overcome this problem, hybrid neutralization of metal and metal oxide inside the same suspension has been preferred while preparing a nanofluid suspension. In a plenty of studies, this approach was tried and promising results were provided. In this experimental study, the single and hybrid utilization of nanoparticles in nanofluid preparation process was studied, and the influences of each were investigated in a plate and concentric tube heat exchangers. Both the single and the hybrid nanofluid suspensions were prepared by mixing the nanoparticles with deionized water and Triton X100 surfactant. While kaolin was used in single-type nanofluid preparation, copper oxides, alumina hybrid nanoparticles were preferred for the hybrid nanofluid preparation process. In both suspensions, distilled water was employed as the base fluid. Furthermore, the mixing ratio of hybrid nanoparticles was constant as 50-50. It is clear in these tables, the chemical composition of kaolin and some properties of the copper oxide and alumina nanoparticles can be seen. It's clear in these tables that metal oxides have high thermal conductivity values. In order to obtain more homogeneous and stable suspensions, each nanofluid suspension was subjected to the ultrasonication process for nearly 3 hours. The tests were carried out 3 times, both for distilled water and prepared nanofluid suspensions, and the average values are utilized in theoretical analysis. The plate heat exchanger utilized in the experiment has 20.8 cm plate length, 7.5 cm plate width, and 0.04 cm plate thickness. The chevron angle is 60 degrees. As to concentric tube heat exchanger, it has 250 cm² effective heat transfer area. The schematics of the plate heat exchanger and concentric tube heat exchanger can be seen in this figure, in these figures, respectively. The tests in plate heat exchanger were utilized by using both distilled water and kaolin distilled water nanofluid under varying Reynolds number, ranging from 1500 to 4000, and the changes in overall heat transfer coefficient were investigated. Furthermore, concentric tube heat exchanger experiments were run under parallel and countercurrent flow layouts. To provide the effects of single and hybrid nanoparticle usage in nanofluid preparation process, concentric tube heat exchanger experiments were performed using both kaolin distilled water and copper oxide alumina distilled water nanofluids, and obtained findings were compared to each other. As to theoretical analysis, the overall heat transfer coefficient of the plate heat exchanger was calculated using this equation. In this equation, U is the overall heat transfer coefficient, Q dot is heat transfer rate, AF is the effective heat transfer area, and finally LMTD denotes the logarithmic mean temperature difference, which is also calculated using this equation. In this equation, H, C, in and out represent the hot, cold, inlet and exit temperatures of the fluid respectively. The Reynolds number was also calculated using this equation. In this equation, m dot is the mass flow rate, dH is the hydraulic diameter, and mu is the viscosity of the fluid. In other respects, the overall heat transfer coefficient of the tubular heat exchanger was specified using this equation, where AT denotes the total heat transfer area, U is the overall heat transfer coefficient, T3 is the inlet temperature of the hot fluid, T6 is the exit temperatures of the hot fluid, while T7 and T10 are the inlet and exit temperatures of the cold fluid passage respectively. The obtained results when it comes to obtained results from the experiments, it is seen that the kaolin nanoparticles doped into the distilled water had positively affected the overall heat transfer coefficient. The maximum increase in the overall heat transfer coefficient was obtained as 9.3%. As far as the test results for concentric tube heat exchanger were considered, it was observed that both single and the hybrid utilization of nanoparticles in nanofluid preparation process improved the heat transfer characteristics, specifically the overall heat transfer coefficient, as you can see in these figures. In parallel flow layout, the increment rate in overall heat transfer coefficient was calculated as 12%. On the contrary, this rate was 37% under counterflow layout condition, when kaolin distilled water was used as the working fluid in heat exchangers. The overall heat transfer coefficients of the concentric tube heat exchanger for hybrid nanofluids in parallel flow and counterflow layouts can be seen in this figure. When copper oxide alumina distilled water was used as a working fluid, the increment rates were calculated as 13.5% and 11% for parallel and counterflow layouts respectively. As can be seen from these results that unitary type nanoparticle usage took place more effectively than hybrid utilization of nanoparticles in parallel flow layout. Nevertheless, in counterflow layout, the less increment rate in the overall heat transfer coefficient was observed in kaolin distilled water nanofluid compared to zinc oxide alumina distilled water hybrid nanofluid suspension. As a conclusion, the influences of single and hybrid nanofluid usage on the thermal performance of plate and concentric tube heat exchangers were studied. The kaolin distilled water and copper oxide alumina distilled water nanofluids were prepared and tested in a plate and concentric tube heat exchanger respectively. With the utilization of single type nanofluids, the overall heat transfer coefficient of the plate heat exchanger can be improved up to 9.3%. Similarly, in concentric tube heat exchangers, when hybrid nanofluid was used as a working fluid, the increment rates were obtained as 13.5% and 11% for parallel and counter flow layouts respectively. For kaolin distilled water, these values were obtained as 12 and 37%. The outcomes of this study revealed that hybrid nanofluid can enhance the performance of both plate and the concentric tube heat exchangers. Thank you for your attention.
Thank you very much to Erdem Çiftçi. I think he is not connected to the Zoom, to the hall. Therefore, we will give the presentation to Ludmila again. Dear Ersin Bahçeci, I think you will manage this because I couldn't manage it.
Afternoon, dear participants of the conference. We present to your attention a report on topic Innovative Proposal for Wind Solar Power Plant. Prepared by the team of authors of Sumy National Agrarian University, Ukraine, Lyudmila Roskova, Marina Savchenko-Pereva, Oleg Radchuk. Speaker Marina Savchenko-Pereva. Only sustainable development of humanity, according to the UN Commission, can ensure the further progress of life on Earth with the satisfaction of the needs of society, while not threatening their ability to meet the needs of future generations. However, implementation of such a development is impossible without guaranteed compliance with energy needs. Currently, humanity is limited in energy consumption because available generation capacity is insufficient. New energy technologies are not used globally and their development leaves much to be desired. It should be noted that the existing methods of energy transfer inhibit its uniform distribution since long-range power transmission is accompanied by significant losses. In addition to the high cost of equipment, the processes of long-range energy transmission lead to significant energy losses, according to some data, up to 20% of the amount of power generated. Thus, further development of centralized power generation and its transmission may lead to significant losses. On the other hand, traditional energy, which uses fossil fuel and energy resources, is a threat to a stable climate and planet ecology. The main hazard is an increase in the atmosphere temperature, as well as its pollution. Developed countries of the world are elaborating new doctrines on fuel and energy complexes which provide for the global introduction of alternative energy sources, such as wind and solar ones. At the present stage of development there are global problems, the solution of which depends on the future of all mankind. One of such problems is energy and resource saving. As energy needs increase many times over, the cost of energy increases and the reserves of traditional energy sources are depleted. Added in the ecological crisis due to the use of planetary resources. Climate change can lead to catastrophe for humanity. The solution to this problem is the use of alternative and renewable energy sources, as well as the maximum use of the generated thermal energy discharged. Such sources directly include wind energy, solar energy, low-temperature thermal energy of various environments, both natural, land, air, reservoirs, etc., and artificial, secondary resources, sewage waste, hot water, etc. Thus, The introduction of power plants that use the above-mentioned sources of energy in enterprises of various branches of industry can be justified both economically and in terms of ecology. At present, the total volume of energy wind in the EU is 142 gigawatts, representing 11.4% of all energy needs. Most new wind turbines were in Germany and Poland. As experience gained during the implementation of low-capacity wind turbines has shown that they can be the most promising in Ukraine. Small wind energy, depending on the capacity, can have the following consumers: 0.020 to 0.024 kilowatts, local backup lighting, 0.060 to 0.075 kilowatts, yachts, 0.20 to 0.24 kilowatts, suburban summer residents, 0.60 to 0.75 kilowatts. The average Ukrainian family, 0 to 4 kVt. Small families under private agricultural enterprises, 6.0 to 7.5 kilowatts. Small farms, 20 kilowatts. Small villages, hamlets. Medium and large farmers, state lands, 50 kilowatts. Agricultural and food private mini enterprises. This slide shows the classification of wind turbines by the location of the wind turbine: 1 single-blade wind turbine, 2 two-bladed, 3 three-bladed, 4 multi-lobed, the so-called chamomile, 5 cup anemometer, 6 rotor of Savona, 7 Darius rotor, 8 Musgrove rotor, 9 Evans rotor. This slide shows the comparative characteristics of the blades of different configurations for the location of the wind wheel. Currently, low-power wind turbines with both horizontal and vertical axes of rotation are used. Dependence of the power factor, senior on the speed theta for wind turbines with a horizontal axis of rotation numbered 3 three-blade wind turbine, 4 two-bladed, 5 multi-blade chamomile, and vertical axis of rotation numbered 6 Savona rotor, 7 Darius rotor. Numbers 1 bets test 0.59, 2 GUS criterion showing ideal wind wheels. The analysis of the proposed types of low-power vertical axial wind turbines showed that the propeller screw of the Savona wind turbine is mainly used. Wind power efficiency indicators are predominantly in the range CP less than 0.35. An exception may be wind turbines with a wind concentrator. The cost of 1 kilowatt of installed capacity is reported to range from 4,000 to 7,000 euros. In our opinion, in Ukraine, as an independent point of low power, and especially in the food industry, it is advisable to introduce a new type of vertical axial wind turbine with an average speed of rotation with blades with profiles of an original shape called open wings. They are characterized by wind turbine to light in general, the ability to operate at low speed 2 meters per second and in any wind direction. This was confirmed by the studied model and experimental samples of vertical axial wind turbine rotors with these blades. In addition, the operating demonstration model of such a wind turbine also confirmed the presence of self-start operation in a wide range of wind speeds and showed the absence of increased noise and icing. In addition, the most important thing is that these data have a sufficiently high efficiency. Comparison of the energy characteristics of wind turbines of vertical axial wind turbines shows that a wind wheel with not closed blades has a very high coefficient of wind energy use CP. In addition, the average fast speed causes a reduction in requirements for durability and reliability design wind turbine compared with fast speed. And the vertical position of the shaft improves performance. Characteristic wind turbine simplifies obtaining not only electricity but heat and mechanical energy, which is important in terms of businesses. matching capacity and performance clause with the consumer has some people opportunities to that instability is caused by the characteristics of the wind. If the rotor clause directly connected with the equipment necessary will provide wall compliance, not only power wind turbine and equipment but the chief of thawing torque and speed. Thus, the relevant characteristics of the equipment that consumes energy, causing the selection clause of the provision of the rotor within the specification. Where the utilization of wind energy is the maximum or the value of its decline is permissible. It is clear that where the wind speed changes in parameters of the clause. Therefore, there may be pauses in the consumer's work, which is sometimes extremely unacceptable. Therefore, it is advisable to implement storage devices. Recently, there has been an increase in activity in the development of thermal energy accumulators. For example, adsorption thermotransformers are proposed, where thermal energy is accumulated in the form of thermochemical potential of the solvent and can be stored for a long time with almost no losses. The authors emphasize that the above heat accumulators are an effective tool for energy conservation, which contributes to the involvement in the energy cycle of renewable energy sources with unstable characteristics. The use of model samples of the rotor of the vertical axial WT of medium speed with a new type of blades will create an effective in the wind conditions of Ukraine and relatively cheap wind turbine, the introduction of which will be appropriate as an autonomous. It is necessary to conduct a study of the experimental sample of the rotor to clarify the characteristics in the conditions of Ukraine and with several options for the number of blades. The basis for the project is the results of research of model samples of rotors of vertical axial wind turbines of medium speed with blades of a new type. Thanks to the organizers for the creation of the conference and the opportunity for the participation of Ukrainian scientists. Thank you for attention. The report was prepared by Savchenko Perov and Marina.
Thank you, Dr. Marina. Dear participants, welcome to our afternoon section again. My name is Deniz Yüzbaşıoğlu from Gazi University, co-chair this section. I would like to say welcome Professor Dr. Fatma Ünal, who is chair of this section, and the next speaker. She will talk about genotoxicity of two nanoparticles, titanium dioxide and zinc oxide. Professor Dr. Fatma Ünal.
Thank you very much. Can you see Deniz?
Yes, I can see.
Yeah. And you can hear me?
Yes.
Yeah, okay, thank you very much.
But presentation is not seen.
You cannot see the presentation.
Yes.
I made sharing my screen.
Okay.
New share. Can you see now?
We see your screen, but you need to switch on your presentation.
Professor, if you want, I share for you.
Yes, please. But I have got one video, and without video, I would like to leave. That's why. Deniz, can you share it?
I tried.
Hocam siz PPT mi istiyorsunuz?
PPT.
PPT istiyorum. Evet. Onun
Siz
üstünde.
açmanız lazım ki siz hareket edeceksiniz hocam. Ben açarım ama ben
Evet
hareket
işte
ettim.
açıyorum ama
Geldi hocam şu
geldi
anda.
mi? Heh,
Evet,
tamam.
5'e bastığınız anda başlayacaktır.
Tamam mı?
Evet hocam.
Tamam Sayın Hocam.
Tamam. Okay. Hello again. You are welcome to the conference. For new joint participants, my name is Fatma Ünal. I am working in the Department of Biology at Gazi University, Ankara. Today, I am going to talk on the genotoxicity of two nanoparticles, titanium dioxide and zinc oxide. First of all, I give you some background on the applications and toxic potentials of nanoparticles, and then the aim of this study. Later, I will continue by giving the materials and methods and the results we obtained in this study. Then I will briefly discuss our results and genotoxic mechanisms of nanoparticles, and why genotoxicity studies are important for human health. I will finish by giving the conclusion of this study. In recent years, nanoparticles, especially metal oxide nanoparticles such as titanium dioxide and zinc oxide, are increasingly produced and used for different purposes. Because nanoparticles have unique physical and chemical properties compared to their bulk forms, therefore, there is a tremendous growth of new applications using various nanoproducts, especially in industrial and medical applications. Titanium dioxide nanoparticles in used, especially in medicine and pharmacy, and again, they are used in food, agriculture, cosmetic industry, and in nanoelectronics, environmental protection, and building engineering. Titanium dioxide nanoparticles are used in sunscreens, food additives, ointment, topical products, plastic, rubber, electronic devices, biosensors, pigment, cement, and coating. Due to such a wide and common usage, exposure to metal oxide nanoparticles has growing every day. Therefore, there is a concern on the negative impact of nanoparticles on human health. Earlier in vitro and in vivo investigations carried out revealed that titanium dioxide and zinc oxide nanoparticles may induce some toxic effects such as breakdown of the membrane lipids, constriction of nuclear membrane, damage in DNA, aberrations in chromosomes, gene mutations, induction of oxidative stress, apoptosis, and even lung inflammation. However, some other nanoparticles did not induce toxic effects in different cell lines, organs, or organisms. All these results show that, on the one hand, there is an increasing number of nanoparticles in human life. On the other hand, there are many controversies regarding the safety of nanoparticles. And most importantly, the impact of nanoparticles on human health is still unknown. Therefore, due to all these reasons, the aim of this study was to investigate genotoxic and cytotoxic effects of titanium dioxide and zinc oxide nanoparticles in human lymphocytes using chromosome aberration, sister chromatid exchange, micronucleus, and comet assays. The materials we used were obtained from Sigma. Some of their characteristics were given in this slide. However, to determine physical and chemical characteristics, scanning electron microscopy and dynamic light scattering were also used in this study. To determine genotoxic potentials of nanoparticles, human lymphocytes were treated with 5 different concentrations of both nanoparticles for 24 hours and 48 hours in chromosome aberration, sister chromatid exchange, micronucleus tests. In comet assay, 30 minutes were used. To determine chromosome aberrations, sister chromatid exchanges, micronucleus, and DNA damages, slides were evaluated by examining quite a lot of number of slides. In addition, mitotic index, replication index, and nuclear division indices were also determined. Data obtained from treatment group were compared with their control groups by using statistical analysis. What we have observed in this study, here we of nanoparticles given by the manufacturer. The other characteristics were determined in this study. For example, scanning electron microscopy showed that both of these nanoparticles were spherical in shape, and they were between 10 and 360 for titanium dioxide nanoparticles, and they were between 10 and 320 nanometers for titanium dioxide nanoparticles in dimensions. Dynamic light scattering showed that these nanoparticles have 804 and 495 nanometers in size. Their zeta potentials were determined as -24 and -27 for both nanoparticles. Slides were evaluated in terms of, to determine chromosome aberrations, slides were evaluated in terms of structural and numerical aberrations. Here we can see some of the structural chromosome aberrations induced by nanoparticles. In this image, we can see chromatid break. We can see chromosome break. There is a fragment in this image, and there is a dicentric chromosome in this image. And we can see sister chromatid union in this slide. In addition, numerical aberrations were also induced by these nanoparticles, such as polyploidy and endoreduplication. In this slide, we can see sister chromatid exchanges induced by nanoparticles here, here, here, and here. These nanoparticles also induced micronucleus in human lymphocytes. In the first slide, we see one micronucleus in a binucleate cell. In the second one, there are two micronuclei in binucleate cell and 3 micronuclei in binucleate cell. These nanoparticles also induced DNA damages that were determined by COMET assay. In the first image, we can see control cell, and in the other images, we can see small damage, medium damage, and large damages in human lymphocytes. In this table, we can see the concentrations of both nanoparticles that increase the frequency of chromosome aberrations, chromosome aberration per cell, sister chromatid exchange per cell, and the frequency of micronucleus and damages in DNA. All these red arrows show that these concentrations increased these aberrations significantly compared to negative control. These results show that these nanoparticles induced genotoxic effect in human lymphocytes. On the other hand, these nanoparticles decreased the frequency of mitotic index compared to negative index. These results show that these nanoparticles have cytotoxic effect in human lymphocytes. All these tests are very sensitive and informative for the determination of genotoxicity and biosafety of nanoparticles, because increased frequency in chromosome aberrations, sister chromatid exchanges, micronucleus, and DNA damage in peripheral lymphocytes are extensively used as a biomarker of cancer, because in cancer cells, there are both genetic damage and chromosome damages. show that both titanium dioxide and zinc oxide nanoparticles induced genotoxic effects and cytotoxic effects in human lymphocytes. Therefore, they may have toxic potential in human health. The results of these and previous studies revealed that nanoparticles both positive and negative effects in cells. These differences in the shape, size and size distribution, crystalline structure, and electrical charge of the nanoparticles. In addition, cell line, organs, and organisms used, test systems, exposure method and period, concentration, and preparation protocols are also important parameters changing the effect of genotoxicity of nanoparticles. Due to limited time, I don't want to discuss all these studies, but I just want to give genotoxicity of genotoxic mechanisms of nanoparticles proposed in the literature. Genotoxicity of nanoparticles can be classified in two different ways, primary and secondary genotoxicity. The primary genotoxicity exists in two types. These are direct or indirect interactions of nanoparticles with genetic material. Indirect genotoxicity, nanoparticles cross the nuclear membrane and interact with DNA directly, and they induce mutations. Or nanoparticles get access to the nucleus during the cell division, and they interact with chromosomes or chromosomes, and they may induce chromosome or chromatid aberrations. Indirect toxicity is induced by the interaction of nanoparticles with nuclear proteins that are important for DNA replication, transcription, translation, cell cycle checkpoints, and antioxidant defense mechanisms. Secondary genotoxicity is produced by the production of reactive oxygen species during inflammation and its interaction with DNA. In why genetic damage is important for us? In cancer cells, there are mutations in certain types of genes and chromosomes. Therefore, agents that cause mutations of genes and chromosomes may also have cancer risks. As we can see, nanoparticles may induce damages in cells via direct or indirect ways and may lead to mutations and aberrations and possibly various types of cancer. Therefore, in conclusion, we can say that understanding the interaction between nanoparticles and cells has twofold importance. On the one hand, it will help us to develop more safe nanoparticles that could be used for specific applications such as drug delivery, cancer therapies, biosensing, etc. On the other hand, it will allow us to be more aware of potential risks for human health. Therefore, more detailed in vitro and in vivo genotoxicity studies using different methods should be carried out for the safe usage of nanoparticles. Thanks to Funda Demirtaş Korkmaz, Zekiye Suludere, Özlem Erol, and Deniz Yüzbaşıoğlu. Thanks Gazi University for financial support, and thanks for your attention.
Thank you, Professor Fatma Ünal. Very informative presentation, your presentation. Is there any question, Professor Ünal? Okay, there is no question. May I ask you a question, dear Ünal?
Yeah, of course.
which nanoparticle is more genotoxic, zinc oxide or titanium dioxide?
In fact, titanium dioxide seems to be more effective compared to zinc oxide, but when we used the same concentrations to determine usable concentrations of these particles, we have seen that when we use the same concentrations, titanium dioxide was more toxic compared to titanium dioxide. Therefore, zinc oxide nanoparticles were lower than titanium dioxide nanoparticles. So the concentrations are different in this experiment. Maybe zinc oxide looks a bit less effective or less toxic, but this difference may resulted from the difference in the concentrations. Therefore, zinc oxide seems more effective to titanium dioxide. Is that enough?
Thank you very much. Yes, enough.
Okay.
Yeah, I would like also to ask speaker, and I have more or less a technical question related to the nanoparticles. Did you carry out your experiments in dark or under radiation, under light?
No. In the cabinet.
I see. I understood.
Yeah, in the in vitro conditions without UV light or other things.
I see. Understood. Okay. But did you take into account that these nanoparticles can absorb light, and maybe you will have different results in dark and at light?
Might be, yes. Yeah.
Okay.
Yeah.
Okay.
Thank you very much.
And what's your opinion? How the size of nanoparticles can affect on the toxicity?
As I show in the slides, it is interesting, especially if nanoparticles are under 100 nanometers, are more effective than their bulky forms because they enter the cell or nucleus more easily. But especially if they are under 30 nanometers, they are more effective than the others, as far as I have seen and I have read from the literature.
Okay, thank you. And the last question, what's your opinion how the shape of nanoparticles can affect on the internalization process?
The shape also affect internalization of nanoparticles into cell or nucleus because small particles are more effective in internalization. But as I show again in the slides, there are many parameters affecting the entrance of nanoparticles into cell or into nucleus. Nanoparticles have agglomeration characteristics. If they agglomerate, if they produce big agglomeration, then they cannot enter the cell or nucleus, and they can't affect, they don't induce toxicity. So there are many parameters affecting this toxicity.
Okay, thank you so much.
Thank you very much.
Thank you. And next speaker is Ece Dimici. Ece is here?
Yes, I'm here.
Okay. You will start, please.
Okay. Hello, dear guests. Today I will present our study titled as Investigation of Gadoversatamid Genotoxicity in Human Peripheral Lymphocytes by Micronucleus Test. By the way, I am Ece Dimici. I'm a research assistant at Gazi University Biology Department. Firstly, I will mention about magnetic resonance imaging. MRI is the radiological imaging technique that has capacity to recognize soft tissues and also usable in children and pregnant women. The field of usage of MRI, mostly brain, cerebellum, spinal cord, and disc diseases, also musculoskeletal system and abdomen and thorax. Sometimes MRI has insufficient contrast to differentiating the part of bodies from each other. At that time, contrast agents are used mostly during MRI examinations. Contrast agents increase the contrast of structures or fluids. That's why it enables more accurate diagnosis and it enables better identification of lesions. Therefore, it has an increasing use day by day in examinations. Gadolinium-based contrast agents mostly use contrast agents in MRI. These are paramagnetic agents which compose of lantinic metal gadolinium. Gadolinium-based contrast agents were believed to be safe and well tolerated in the body, but literature reviews about their toxic effects, there were both positive and negative results about their toxicity. Gadoversetamide is one of the most used gadolinium-based contrast agents, which is linear and non-ionic one. And there is limited information on gadoversatamide's genotoxic risks. Therefore, the aim of this study is to investigation of genotoxic potential of gadoversatamide by micronucleus test. If we look at the materials and methods, firstly, peripheral blood from 3 donors obtained who were non-smokers and not exposed to any genotoxic agents in the last months. The concentrations of gadoversatamide were chosen according to their its lethal dose and recommended dose in human. Its lethal dose in mice was 25 millimole per kilogram, and its intravenous dose in humans is 0.1 millimole per kilogram. So the concentrations selected were started from 7,000 microgram per milliliter to 112,000 microgram per milliliter. There were also used negative control as distilled water, and positive control was mitomycin C. The micronucleus test procedure is like this. Firstly, peripheral blood added to the medium, and this was incubated at 37 Celsius degree, about 72 hours. The treatment of 5 concentrations of gadoversatamide performed at 24th hour of the incubation. After that, at the 44th hour of incubation, the stacolacin B was added to block the cytokinesis of the cell division. After that, the 72nd hour, the incubation was ended by centrifugation. After that, potassium chloride solution was added as hypotonic solution, and then the cells fixated 3 times. After that, cells were spread on the slides in order to be analyzed under microscope. If you look at the analysis, for the micronucleus analysis, 1,000 binucleated cells per donor was analyzed. We have 3 donors, so totally 3,000 cells were analyzed. For nuclear division index, again per donor, we analyzed 500 cells, totally 1,500 cells with 1 to 4 cells. If you look at the results, gadoversetamide induced biniplates with 1 micronucleus in human lymphocytes. You can see here the micronucleus. And if you look at the table, here is the treatment. This is period, and these are the concentrations. Negative control, positive control, mitomycin C, and gadoversetamide treatments. Here, binucleated cell scores, all of them is 3000, and number of binucleated cells including 1 micronucleus for all the treatments, micronucleus and nuclear division index. If you look at the gadoversetamide treatments, we can see in MN section, micronucleus section, we can see the increasing according to dose, except the lowest concentration by comparing to negative control. And only the highest concentration has the statistically significant difference. If you look at the nuclear division index, again, we see the gadoversetamide treatments cause some declines according to comparing by negative control, but none of these declines were significantly, were statistically significant. If I conclude the results, micronucleus test widely used in human and mammalian cells, which is so reliable and sensitive, and it enables genotoxic, cytotoxic, carcinogenic, and mutagenicity of physical and chemical agents effects. Gadoversetamide in this study caused an increase in micronucleus frequency compared to negative control. Only the highest concentration was significant. If you look at the nuclear division index frequency, gadoversetamide caused decline compared to negative control, but none of these declines were significant. So we can say that gadoversetamide caused significant micronucleus frequency at its highest concentration. That is why it may be weak clastogenic and or anogenic effect in human lymphocytes. But of course, further investigations should be conducted on the genotoxicity of gadoversetamide for the safer usage of this agent. Thank you for your attention. If you have any questions, please ask me.
Is there any question for Ece Dimici? I think no question.
Okay.
Thank you, Ece.
Thank you, Professor Yüzbaşıoğlu.
Okay. The other four presentation is our poster presentation, and the first is cytotoxic and genotoxic effects of iron oxide nanoparticles on allium cepa from Derya Kızılkaya. The host is Professor Ünal.
Okay. So I will share the screen.
Okay.
Okay, now it's Derya's turn.
Professor, if you want, I could share for you.
Okay. Sorry.
The title ID is 518. Is correct?
Yes.
Okay.
Yes. Yeah.
Please, you closed your share, your screen share.
Is that okay?
No. Share screen is closed. Not closed, no.
Sorry about that. Stop share.
Yeah, okay. Thank you.
Dear participants, welcome to my presentation. I am Derya Kızılkaya. I am doing a master degree at Gazi University. Today, I will talk about cytotoxic and genotoxic effects of iron oxide nanoparticles on alluvium cepa. First, I will talk about nanotechnology, nanoparticles, and iron oxide nanoparticles. Then I will give information about alluvium tests I used in my own study. After that, I will talk about cytotoxicity and genotoxicity tests. Finally, I will talk about materials and methods, my own study results and consideration. What is nanotechnology? Nanoscience and nanotechnology are the study and application of extremely small things, can be used across all the other science fields, such as chemistry, biology, physics, material science, and engineering. Nanoparticle is a small particle that ranges between 1 to 100 nanometers in size, at least in one dimension. Industrial nanoparticles are divided into four classes: carbon-based, metal-based, dendrimer, and composites. Iron oxide nanoparticles, metal-based, are currently used in biomedical applications such as tissue repair, immunoassay, detoxification of biological fluids, cell separation, magnetic resonance imaging, and drug transport. Iron oxide nanoparticles used magnetic resonance imaging, drug and gen transport, food additives, cosmetics, treatment of hypothermia, environmental decontamination application. However, some investigation in recent years show that iron oxide nanoparticles can be cytotoxic and genotoxic. Therefore, this study aimed to investigate the cytotoxic and genotoxic impacts of iron oxide nanoparticles using an indicator organism, alluvium cepa. Yes, I will talk about alluvium test. What is alluvium test? Alluvium test is used as a genotoxicity test to determine potential risks and adverse effects of various nanoparticle food additives, drugs, and pesticides. Allium test is an inexpensive and reliable test. Allium SEPA is very useful because it has large and few chromosomes. Chromosomal aberration can be easily observed and can be grown in most of the years. Yes, what is cytotoxicity and cytotoxicity tests? Cytotoxicity is defined as the toxicity induced due to action of physical and chemical agents of living cells. The cell viability or cytotoxicity is generally measured by various tests. MTT tests, allium tests, and Ross reactive oxygen species methods are RFE methods used for cytotoxicity. What is genotoxicity? Genotoxicity describes the property of chemical agents that damage the genetic material within a cell, causing chromosome aberration and/or mutation, which may lead to cancer. Chromosome aberration test, allium test, and comet assay. Some of the genotoxicity tests used generally. Yes, I would like to talk about my own study. I used for different concentration of iron oxide nanoparticles. Size is smaller than 50 nanometers, and we are administered to union root tip for 24 hours. Distillated water and hydrogen peroxides were used as negative and positive control, respectively. Root tips were cut and preserved in 70% alcohol at 4 centigrade degree. Root tips were hydrolyzed, stained, and Sukai slides were prepared. Slides were scanned under light microscope to detect mitotic index for cytotoxic effect, chromosomal abnormalities for genotoxic effect. Yes, in this study, we observed that all the concentration of iron oxide nanoparticles significantly decreased the mitotic index compared to negative control, and cytotoxic effect increased. All the concentration of iron oxide nanoparticles significantly increased the frequency of mitotic chromosome abnormalities dose-dependently, and genotoxic effect increased. Here we can see some aberration induced by iron oxide nanoparticles, stiffness at metaphase, disturbed prophase, chromosome breach at anaphase. In conclusion, this study revealed that iron oxide nanoparticles have cytotoxic potential in allium SEPA root tip cell. These results also show that iron oxide nanoparticles have genotoxic effect in allium SEPA root tip cell. In conclusion, properties of nanoparticles such as shape, surface area, aggregation tendency, surface charge are important factors in creating toxicity. These particles, which are very small in size, reach our lungs via the respiratory tract and penetrate to human beings. Cytotoxic and genotoxic effects may result from either by direct interaction of nanoparticles to genetic material or by the generation of reactive oxygen species such as hydrogen peroxides and superoxide radicals. Thereby, nanoparticles may induce damage in DNA chromosomes, even cell deaths. Therefore, more and detailed genotoxic studies should be conducted in different cell types and organisms for safe usage for nanoparticles. Thank you for your attention.
Professor Deniz, your sound.
I am sorry. Next speaker, İrem Funda Duran. She will talk about genotoxic effects of rod-like titanium dioxide and pedot-coated rod-like titanium dioxide nanoparticles on human lymphocytes in vitro by micronucleus test.
Sayın Hocam, ben paylaşıyorum.
Evet hocam.
Hello, my name is Iran Funda Duran. I am a student Gazi University. This study genotoxic effect rod-like titanium dioxide and pedot-coated rod-like titanium dioxide nanoparticles on human lymphocyte in vitro by micronucleus test. Nanoparticles are commonly used in different areas such as medical and personal care products, sensors, electronics. Metal oxide nanoparticles smaller than 100 nanometers, especially titanium dioxide, are the most widely used group in nanotechnology. They can either used alone or coated with different materials to gain more specific properties. Although they have many beneficial advantages, these nanoparticles might induce adverse effects on humans and other organisms. Therefore, the genotoxic potential of rod-like titanium dioxide nanoparticles, pedot-coated rod-like titanium dioxide, and pedot nanoparticles was investigated in human peripheral lymphocytes in vitro. Human peripheral lymphocytes were exposed to rod-like titanium dioxide nanoparticles. Pedot-coated rod-like titanium dioxide nanoparticles 50, 100, 250, and 500 microgram per milliliter, and pedot nanoparticles 5, 10, 25, and 50 microgram per milliliter, and processed for micronucleus test. Micronucleus were evaluated in 3,000 phosphate metaphases. While all nanoparticles induce nucleated cells with 1 and 2 micronucleus in some treatments, none of them was significant compared to the negative controls, except 25 microgram per milliliter pedot. Therefore, they cannot be reported as genotoxic. However, in the literature, studies are revealing genotoxic potential of this or other kinds of titanium dioxide nanoparticles. Conflating might be due to the space size, coating, surface thickness, concentration, intercellular uptake difference, reported DNA or chromosome damage were supposed to be the result of the primary and secondary genotoxic mechanism of nanoparticles. These domains are directly or indirectly correlated with virus illnesses and especially with cancer development. On the other hand, while nanoparticles do not induce genotoxicity, they might affect the immune system. Due to all these reasons, it is important to do more in vitro and in vivo study using different concentration and different test systems to use nanoparticles safely. Thank you for listening.
Thank you, İrem Funda Duran. Next speaker is Koray Akkurt. ID number 63.
Mr. Bahçeci? Yeah. Thank you.
Hello, my name is Koray Akkurt. I am a master degree student at Gazi University. I want to present my study about the comparison of genotoxicity of needle-like and spherical titanium dioxide nanoparticles assessed by chromosomal aberration assay in vitro in human peripheral lymphocytes. I want to give some introductions about this study. Nanoparticles are at the leading edge of the rapidly developing area of nanotechnology, and titanium dioxide nanoparticles are widely used in dyes, cosmetics, textile, food, plastic, medical, space, and military industries. However, these nanoparticles may have toxic and or genotoxic effects in cells and organisms. Therefore, this study was planned to compare the genotoxic potential of needle-like and spherical titanium dioxide nanoparticles by using chromosome aberration assay in human lymphocytes in vitro. In this study, we provided peripheral blood specimens from 2 male and 1 female donors were treated with 4 concentrations: 125, 250, 500, and 1000 micrograms/milliliter. And also we used an titanium dioxide nanoparticle needle-like form and spherical form, you can see. And also we used a negative control, which is chromosome medium B, a solvent control, which is distilled water, and a positive control, which is mitomycin C. And also, chromosome aberrations were evaluated in 300 well-spread metaphases, the frequency of aberrant cells and the number of chromosome aberration per cell were determined. This study was also approved by the Gazi University Ethical Committee. When we see the results, both types of nanoparticles induce chromatid and chromosome break, fragment, sister chromatid union, and dicentric chromosome. Also, polyploidy, which is a numerical aberration, was also determined. Increasing dose dependent in most of the applications and significant especially at the highest concentrations compared to negative and or solvent controls at both treatment periods. As a conclusion, these results indicate that both forms of titanium dioxide nanoparticles have low clustergenic effects. On the other hand, needle-like induce slightly higher aberrant cell and chromosomal aberration per cell compared to spherical form. This might be the result of a higher electron density transfer of needle-like to the interacting cells. It was reported that the DNA damages may result from the generation of reactive oxygen species, which is supposed to play an important role in genotoxicity of metalloxide nanoparticles. Besides, numerous investigations have suggested that titanium dioxide nanoparticles trigger reactive oxygen species-mediated single and double-strand-free generation of DNA ducts, chromosomal damage, and generation of alkaline label sites. All these data indicate the necessity of further in vitro and in vivo studies of these nanoparticles, not only for risk evaluation but also for approving safe by design procedures to get rid of or diminish some of their toxic effects. Also, you can see the results here graphically here. Thank you for listening. Have a nice day.
Thank you, Koray Akkurt. The last poster presentation title is Genotoxicity Assessment of Cerium Oxide Nanoparticles in Human Lymphocytes. Speaker is Yasemin Saygılı. ID number 30. Ersin Hocam.
Participants, my name is Yasemin Saygılı. I have completed my PhD degree in the Department of Biology. My subject is genotoxicity assessment of cerium oxide nanoparticles in human lymphocytes. Cerium oxide nanoparticles, or nanoceria, one of the important nanoparticles, are used in the field of biomedical, agriculture, industry, and cosmetics. However, there is limited information regarding their toxic impact on human health. Therefore, in this study, in vitro genotoxic effects of cerium oxide nanoparticles were investigated in human peripheral lymphocytes by macronucleus assay. For macronucleus assay, lymphocytes were incubated with 4 concentration of serum oxide nanoparticles. Serum oxide nanoparticles increase the frequency of micronucleus at all the concentration compared to control. This increase was significant at too high concentration. Serum oxide nanoparticles didn't affect Stokinase block propagation index. In our previous study, serum oxide nanoparticles were found as cubical in shape and showed agglomeration. They induce primer DNA damage at all the concentration and treatment times in peripheral lymphocytes, indicating that serum oxide nanoparticles have genotoxic potential. These results indicate that serum oxide nanoparticles have genotoxic potential in human peripheral lymphocytes. Serum oxide nanoparticles was found to produce reactive oxygen space, which cause damage to cellular components, including DNA. Serum oxide nanoparticles was reported to induce genotoxic and biochemical change at high doses. All these results indicate that serum oxide nanoparticle may have genotoxic potential in humans. However, further investigation needs to be conducted for the safe usage of these nanoparticles. Thanks for your attention.
Thank you very much, Yasemin Saygılı. We are quite ahead of the schedule, in fact. We run quite quickly. Our presenter, Ayşe İhsan and Emin Yusuf Aydın, is here. We don't have their presentation either. Our invited speaker, Dr. Dimitri Gorin, is here.
Yes, thank you.
Would you mind to carry with your presentation?
Yes, I'm ready.
Because I can't see the other presenter and we don't have their presentation either. That's why maybe they don't join the meeting. I don't know.
I see. Okay, I try to share my screen, yeah?
Yes, please.
Okay. Do you see my screen now?
I can see.
Okay, good. Okay.
I can hear you. I can see the slides. Very nice.
Okay. First of, can I start? Yeah.
Yes, please.
Okay. Dear colleagues, first of all, I would like to say many thanks for inviting me, give a talk. Okay, unfortunately, it's online. Okay, maybe next year or later we will meet offline together. Okay, and I would like to share our last results related to preparation of multifunctional multimodal probe. And I would like to pay attention on the synthesis and biomedical applications. I'm from Skolkovo Institute of Science and Technology in Moscow. It's the first international university, and it was made as a result of collaboration of MIT and Russian government. And let's go to the outline of my talk. The first, I would like to say some words about the motivation of my work. Next one, go to the requirements to the multifunctional multimodal probes. And then I would like to share my opinion about the methods of preparation such type of probes. Next step, I would like to share with you our knowledge about how we can prepare bimodal contrast agent and to give us photoacoustic as well as fluorescence signal. And we use for this quenching and enhancement of fluorescence close the plasmon nanoparticle surface. And also we use self-quenching effect. And also I would like to share with you some last results that we have obtained using the high-intensity focused ultrasound for release of encapsulated substances from our probe. And also I will give you a summary of my results and acknowledgements. And then go to the motivation. The main application of this multifunctional multimodal probe is the visualization of central lymph node. It's the nearest node to the cancer, and it's sometimes it's this lymph node play a very important role in metastasis and formation. And next one, angiography. We would like to visualize the blood vessels and as well as lymphatic vessels. And next task is related to interoperative imaging. It's very important if you need to find boundaries between normal and pathological tissue. And if you apply, for example, fluorescent imaging, we can easily to find cancer tissue. It's extremely important for brain operation. And the last but not least, it's labels or probe for detection of circulation tumor cell using the photoacoustic and fluorescence flow cytometry. And I would like pay attention mostly on this last topic and some words what means photoacoustics. If we have objects that can absorb light, and if we radiate this object by pulse laser radiation, this object can absorb this light, and then we can see the thermoelastic expansion and during the irradiation. And if we did not irradiate, we can see the decreasing of size. And then as results, after pulse irradiation by laser, as results, we can obtain oscillation of this object. And as results, this object is the source of ultrasound wave. And we know this ultrasound in megahertz band, it's easily penetrate biological tissue. This is widely used for ultrasound imaging in clinic. And as results, we can record this signal by microphone or sensors. And the main advantage of this technology is that we can penetrate deeply than pure optics methods, because as usually we should irradiate the object and then we should analyze the scattered, absorbed photons or reflected photons. In this case, we irradiate it and then we use the microphone, and the penetration of acoustic wave is highest than optics. It's of course depends on wavelengths. Yeah, and we have in our body many endogenous chromophores, and therefore this method can be applicable, for example, without any contrast agent, for example, for visualization of vessels inside of our body. And we have now commercially available technique in optoacoustic microscopy as well as optoacoustic tomography. For example, one of the company who produce such type of setup, it's ITER Medical from Munich, Germany. And the other possibility, the first, it's using optoacoustic for imaging. And the second one, our colleagues from Arkansas University, Professor Zharov and Professor Galanja, we suggested using the photoacoustic approach for detection of circulation tumor cell in vivo without taking a blood through the skin. You irradiated vessels by laser, and if you found in the vessels circulation tumor cells, it's like melanoma cells. Some line of melanoma cells contains melanin, and melanin absorbs this light, and this cell can play a role as source of ultrasound, and we can detect this ultrasound. And therefore, it's advantage of this method that we can analyze, for example, 30 minutes just by radiation of laser or by laser this vessel, and we can analyze approximately 40 up to 1 liter of blood. And of course, it's not possible to take such amount from patient for analysis, and therefore it's promising technique. And but other possibilities that our colleagues also demonstrated in vivo, but using the animals, that possible by light also destroy these cells. And but unfortunately, most of these cells doesn't have any chromophores like melanin, and therefore we need to prepare a contrast agent that give us optoacoustic signal, and this you see requirements to this probe. And the first, we need to have the highest optoacoustic signal. The second, we need to second modality like fluorescence. Why? Because we need to verify our data. Because we have many artifacts, and therefore we need to be sure that this really our objects that we would like to check. And then very important that we should have on the surface of also some antibodies or other types of vector for selective absorption of the circulation tumor cell. And also we need to have ability to encapsulate drug inside of this shell and use remote release, for example, by ultrasound, remote release of encapsulated substances, drug. We need not only to found this circulation tumor cell, but we would like also to treat and realize the theranostic idea, this imaging, diagnosis, and therapy in one object. And then how we can prepare such type of object? We use one of the techniques that's named layer-by-layer assembly. This method firstly was suggested by Aller in 1966. And he used for preparation such type of layers a positively charged alumina, it's positively charged in neutral pH, and silica, it's negatively charged. And he put glass substrate at the beginning of alumina oxide, it's water suspension of alumina oxide nanoparticles. And then after washing, he put the substrate to the silica colloid, and as a result, the negatively charged agree the Coulomb interaction. They interact with previously positively charged particles and formed next layer. And Aller used optical method for detection that he found realized layer by layer assembly that absorb layer by layer. A little bit later, two researchers that were working at this time in Germany, in Mainz, they suggested used instead of nanoparticles, they suggested used polymers. It's cationic and anionic polymers. And of course, you can also use not only polymers, but you can combine polymers, molecules, and inorganic nanoparticles like magnetides, zinc oxide, and other. And little bit later, in the end of in the end of last century, it's one group that is working at this time at Max Planck Institute of Colloids and Interface Science. They suggested use instead of planar substrate the surface of particles, and they formed like core shell particles using this technology and shell after dissolving of the core. And the next using this technology, we can form the shell on the surface of inorganic nanoparticles. For example, it's gold nanoparticles with polymeric shell. But in our lab, we used polymorph modification of calcium carbonate named vaterite. Why vaterite? Because it's the vaterite particles has porous structure, and also we can dissolve these particles in middle condition. Because, for example, if we take into account calcite particles, they can dissolve at pH 1. And we used, as usually, two type of method for loading these substances by trucks. Two technology, it's adsorption method and co-precipitation method. And in this case, we have obtained low loading efficiency, like 1% and 2% per mass percent. And of course, we are going to increase the loading efficiency. And our postdoc from our group was suggested using for this freezing and thawing induced adsorption method. The idea, if we use mixing of calcium carbonate particles and magnetite nanoparticles, and then we try to freeze this suspension, it's well known that ice crystal use water molecules for formation of this crystal, and crystallization front push out magnetite nanoparticles and calcium carbonate nanoparticles, and as results we obtained adsorption of magnetite nanoparticles on the surface of calcium carbonate particles. And how it's look like in reality, it's a brown colored, it's magnetite nanoparticles with size 10 nanometers, and white colored particles is calcium carbonate particles with size like 3-5 micrometers. And you see formation of ice crystals, and as results we induced adsorption of magnetite nanoparticles on surface of calcium carbonate particles. And then you can see how it's look like. Here, this color of suspension using the co-precipitation, adsorption from water solution, and here it's freezing induced. And you see clearly difference between 7 adsorption cycles and 7 freezing thawing cycles. It's more dark than these tubes. And one of the big advantage of this technology that is you can repeat this technology if you have fridge in your kitchen, fridge with freezing camera, and it's enough for obtaining of the for loading these particles. And fortunately that we have obtained linear dependence of numbers of loading for microparticles and for submicron particles. And fortunately, of course it's not universal approach, but fortunately we can apply this approach not only for preparation core shell structure, but we can use this approach for preparation also shell structure. This means that we can dissolve the core and obtain like freestanding structure. And this approach also we can apply for loading gold nanoparticles and for loading of proteins like albumin. And our colleagues also have already used this method for loading of DNA or RNA, and it's working very well. And then we go to the physical phenomena that we are going to use for preparation of B-model photoacoustic and fluorescence contrast agent. And we use for this idea that published in this work. Here you can see the gold nanoparticles, and if you coated the gold nanoparticles by polymers layers using the layer by layer approach, you can change the distance between dye and surface of these gold nanoparticles. And you can see in case of SiPite, we have optimal distance where we have enhancement of fluorescence. And in case if we adsorb our dye, fluorescence dye, exactly on the surface of gold nanoparticles, we obtained quenching of fluorescence. And then we apply this idea for preparation of such type complex structures that we have in the shell indocyanine green. Indocyanine green, it's fluorescence dye that is widely used in clinical practice for angiography, for example, and it's FDA-approved dye since, I think, 1960. And this, you can see also a layer of gold nanorods, and this very short distance, and we expected that we will have obtained quenching of ICG close the gold nanorods. And this, we have the same structure, but we have encapsulated conjugate albumin with same dye. And here we have long distances, therefore we expect the high fluorescence enhancement of just fluorescence of this conjugate. And here you can see extinction spectra, and we have broad adsorption of our particles in transparent window of biological tissue, and we have good correlation of optoacoustic signal and extinction spectra. And as results, we can calculate the photoacoustic expected photoacoustic signal, and you see the maximum photoacoustic signal. Our expectation, it should be that we have ICG encapsulated with albumin and ICG in the shell together with gold nanorods. But in reality, we obtained maximum signal for structure that has ICG only in the shell, and it's very interesting results. Why it has happened? Because for such type of object, it is necessary to take into account not only amount of adsorber of light, but also mechanical properties. And if you encapsulate albumin indocyanine conjugate, we increase the thickness of shell, and we change the mechanical properties. But you see, our expectation about quenching is working. But for next application for in vivo, we selected the first sample. Why the first sample? Because we have acceptable level of optoacoustic signal, and we have also fluorescence signal. And we injected these probes to mouse, and we obtained both fluorescence signal and photoacoustic signals. And we compare the signals, optoacoustic signal from our particles, just with optoacoustic signals that we obtained from gold nanorods. And we have obtained highest signal by we have big object, this is a bigger volume, and we high enough the chromophores that can absorb of light. But our colleagues, our medical doctors, have asked us about excluding from our structure any inorganic nanoparticles, and we try to think how we can prepare B-model contrast agent using only fluorescent dye, FDA-approved fluorescence dye in the cyan green. How we can do what the phenomena we can use? We use self-quenching effect. Here you can see dependence of fluorescence on the concentration, and started from some concentration, we can see the increasing of fluorescence and then decreasing of fluorescence. And of course, if we decreasing of fluorescence, we can have more energy transfer of thermoelastic expansion, and this is very important for photoacoustic. And what we found also, if we have preloading substances inside of the shell, we obtained less absorption of dye on the shell. It's look like this. If we don't have any preloading conjugate albumin with indocyanine, we have the highest adsorption of this in the shell. And here you can see that we can calculate the amount of ICG in the shell and the amount of ICG encapsulated into the capsules. And here you can see that we have real self-quenching. We use FLIM, fluorescence lifetime imaging. And here you can see the time of fluorescence that we have in the cyanin green only in the shell. And this we have 11 cycle of freezing-induced loading method inside of the shell. And we obtain decreasing the fluorescence lifetime that confirms that we have real fluorescence quenching. And here you can see adsorption and photoacoustic spectra. And we have again broad adsorption in the window of transparency on biological tissue between 600 up to 800 nanometers. And what the interesting results that we have obtained, that optoacoustic signal is completely proportional the concentration of the dye inside of the shell, not all whole concentration of endocyanin green, but it's exactly the concentration that we have in the shell. It's very important results that need this results means that we have inside free volume for encapsulated drugs, and we demonstrate that we can use high intensity focused ultrasound for destroy such type of the shell. And here you can see the results that we injected the shell that contains of dye, encapsulated dye, and gold and magnetite nanoparticles that also can quench our fluorescence dye. And we injected to the legs, mouse legs, this suspension, and then irradiated this leg by high intensity focused ultrasound. And you see, agree the ferments, we have degradation the both legs, but where we have destroyed this our capsules preliminary by ultrasound, we can see increasing of fluorescence. And this is a very important results. Why? Because now in clinic is used this method. It's a high intensity focused ultrasound. Here you can see the movie from real operation. This method is used for hypothermia of prostate cancer. It's under control of ultrasound imaging. We can switch on high intensity focused ultrasound and then induced hypothermia and as a result necrosis of cancer tissue. And it is very important that we can use the same ultrasound but at lowest power density for opening our microcapsules in vivo. And then I would like go to conclusions. I think I can demonstrate you how we can prepare multimodal and multifunctional particles, and you can apply for this really very easy and very reproducible technology. It's like layer-by-layer assembly and freezing-induced loading method, and we can combine for both technology for obtaining photoacoustic and fluorescence signals. And also we can use two phenomena for increasing or decreasing of fluorescence and decreasing or increasing photoacoustic signal. And also we demonstrate the possibility using high intensity focused ultrasound for release of encapsulated substances. And the next slide, I would like to say many thanks our collaborators. First of all, my coworkers from School Tech, and also our colleagues from Saratov State University, University of Arkansas for Medical Science, and Technical University of Munich. And also I would like to say many thanks our colleagues from our industrial partner like Art Photonics, spectroacoustic, and also our colleagues from Moscow State University. And thank you for your attention. Please, questions, comments.
Thank you very much, Dr. Gorin. If you have any question. Is there anyone to ask?
Thank you. Actually, we do have a question. Thank you very much. Your study was very, very interesting, and we hope all the best. I was just wondering, at the beginning, you mentioned that it is possible to keep the shell intact while the core is dissolved. How is that possible? That was very interesting.
I see. That's a good question, and I would like to go to the first slides.
Thank you very much.
Yes, thank you for this question. And we use, okay, in this case, we can use S core, for example, laterite particles, and we can dissolve these particles by some organic substances, ADTA. This particles is used for blood conservation, for example. The idea is that this organic molecule can form complex with calcium ions, and then we can dissolve this core. But it's because our shell, it's a polymer shell, it's penetratable to the calcium ions. The other possibility, you can use also instead of calcium carbonate core, for example, silica particles, or you can use also polystyrol particles. But in this case, you can use organic solvent like hydrofuran or dimethylformamide for dissolving of core. And in this case, it's you can dissolve freely core. It did not dissolve the shell. And you can find many of such type of polymer shells and core. But why we selected the calcium carbonate core? Because it's a very easily and very cheap core, and we published many articles about the optimization, how you prepare. Unfortunately, now we can prepare also submicron particles, because FDA approved for injection of particles this size less than 200 nanometers, and therefore very important to prepare submicron particles. It's look like this, yeah. But thank you for this question, yeah.
Thank you very much. Your study is absolutely phenomenal. Thank you. Thank you so much.
We look forward to the update. Thank you once again.
Thank you.
Any more question? Any question? I think there is no any question. Thank you very much, Dr. Gorin, for your informative presentation.
Welcome. Thank you for invitation.
Dear guests, Emin Yusuf Aydın is here. Emin Yusuf Aydın.
Dear Chair, when you're waiting the others, he is here.
How can we connect to the Zoom?
Professor, I am here.
I can't see you.
Yes, okay. I can start.
If you can share your screen and join to Zoom,
okay.
I will be very happy.
Thank you.
Thank you very much.
First of all, I would like to thank each participant for joining meetings. I am Emin Yusuf Aydın at Musculoskeletal and Regenerative Medicine Department at Ankara Yıldırım Beyazıt University. Today, I am going to present you comparison of the effects of co-use stromal vascular fraction and bone marrow concentrate and their single use on the Achilles tendon. This project was supported by the TÜBİTAK. In the beginning, I would like to talk about the tendon. A tendon is an internal part of muscular tendinous unit. Its primary function is to transmit forces from muscle to rigid bone levers, producing joint motion. While doing this task, the tendon is exposed to many forces, especially tensile forces and high compressive forces. If we look at the structure of the tendon, tendons consist of the collagen, mostly type 1 collagen, and this collagen accounting for 18% of the dry mass of the tendon. And collagen is produced by tenoblasts and tenocytes, which are the specific tendon cells. These lay between the collagen fibers. And also, as can be seen, tendon blood supply is less than other tissue. Tendon healing consists of 4 stages. During this stage, cell proliferation and collagen production is increased. Also, there is an transition between collagen. This is very important because thanks to this change, the tendon will reach a flexible structure that can carry the loads on it. So why don't tendons full heal? There are many reasons for this, but the most important reasons are tendon have a low metabolic rate, limited ability to reproduce, and the most important thing is transition from collagen type 2, type 3 to collagen type 1. We look at the current methods used for tendon treatment. Firstly, pharmacological methods. These methods include non-steroidal anti-inflammatory drugs. In particular, are used for pain relief and matrix production. Other method is surgical method. This method is still used as the only method in tendon ruptures. Third method is physiotherapy methods. It is used to relieve symptoms, especially pain and swelling. Lastly, we use to regenerative medical applications for tendon healing. These are the methods used to restore the tendon to its former health. Now I want to briefly describe the concentration we use in our work. Firstly, vascular fraction. Vascular fraction obtaining stem and stomach cells from adipose tissue. It contains endothelial precursor cells, endothelial cells, macrophages, pericytes, and periadiocytes, etc. And this concentration properties firstly immunomodulation, anti-inflammatory, and angiogenesis. Concentration is bone marrow concentrate. These concentrates include hematopoietic and mesenchymal stem cells, monocytes, endothelial cells, and many growth factors. And these concentrates properties are anti-inflammatory, immunomodulator, pro-angiogenetic, and anti-apoptic. The aim of the study is to evaluate the effects of combined use of stromal vascular fraction and bone marrow concentrate on the Achilles tendon according to their individual use. Our hypothesis is evident that the combined use of SVF and BMAC is more effective in the treatment of Achilles tendinopathy than their individual use. If we look to our methods, we use animal experiment was used for tendinopathy model, and evaluation of tendon healing was performed by electrosonography. In animal experiment, we used 30 New Zealand white rabbits of 6-8 weeks old, and the rabbit's average weight is 2.68 kilogram. There were 7 groups in our experiment, and 5 rabbits were used for each. It can be seen which concentrate was applied to which group. All surgical procedures were performed in the fully equipped operating room. After the anesthesis, partial wounds were opened except approximately 1 centimeter above the calcaneus with the help of a 0.3 centimeter biopsy patch. To perform SVF under anesthesia, a second incision was made to access the bilateral inguinal fat pad. 6 to 8 grams of subcutaneous adipose tissue was removed. Then, first of all, we divide the extracted adipose tissue into very small pieces. Secondly, we put in the collagenous because destroy the extracellular matrix and expose the cells. And at the end of the 1 hour, we first centrifuge the spermicide obtained. And lastly, we pass through use mycometer filters. Then the SVF is ready. While the animal was under anesthesia, bone marrow aspiration from the left trochanter area was performed with an 18-gauge needle. Approximately 2 milliliters of bone marrow was aspirated. Firstly, we dilute the bone marrow with distilled water. Then we add 2 millimeters of fecal PQ to it. Secondly, we put this mixture in centrifuge, and at the end of the centrifuge, we obtain BMEC on the fecal PQ material as shown in the picture. We used electrosonography for evaluation of tendon healing. Electrosonography is non-invasive evaluation of the biomechanical properties of tissues and to produce qualitative and quantitative information. We used 2 rabbits from each group were used for electrosonography. Electrosonographies of rabbits were done at 1 and 2 months after the operation. We obtained strain values and color changes data by electrosonography. Strain values are quantitative data, and these data are displayed by the device. As a number grows, more rigid structures are moved away from the elastic structure, same like tendon. But color changes are qualitative data, and we must use some scales. We used to scale by Tan et al. Thanks to this scale, both flexibility and homogeneity of the structure can be checked. When we look at the electrosonography stress value results, it is seen that individual use is better in the first month. But in the second month, it was seen that the 6th experimental group saw 75% BMEC, 25% SVF, showed the best recovery, and we seen the mixtures recovered faster than individual users. Then we look at the electrosonography color change results. Although all groups tend towards a more homogeneous and flexible structure, the biggest change, but it's seen that the biggest change is again in the 6th group. Looking at the electrosonography all results, 2 important results emerged. First one is especially the mixture groups are very similar to intact tendons, healthy tendons, and second one is the heterogeneous structure correlation seen with the hardness also shows that there is a recovery process there. In the second month, a rigid but flexible structure specific to the tendon tissue occurred. Thank you very much for listening to me.
Thank you very much to Emin Yusuf Aydın for his presentation. Anybody would like to ask a question? Any question to Yusuf Aydın? I think there is no question. Okay, thank you very much to Emin Yusuf Aydın for his presentation. Ayşe İhsan is not here. We only one missing presentation in this session. We are quite ahead of the this section, and we finished quite early. It's about 4:30.
Dear Chair.
Hello, Mr. Ateş.
Hello, how are you?
Fine, and you?
Thank you very much. I'm very well. I am listening your session. Perfect presentation I heard, especially very high level presentation from the Dimitri Korin, my friend and colleague from Russia.
Thank you very much for all the presenters.
Yes, all the presenters. Natalia from Greece, my friend, and Mansur family.
Yes, they look very nice.
Thank you. Thank you.
Dr. Zuhal Ers, students, colleagues, and others, all from Yıldırım Beyazıt University, with chair of the session, Fatma Ünal and Deniz Yüzbaşıoğlu. All of you, thank you very much. It was great work. I feel very better after listening to you, after follow you. Thank you very much. Actually, next time, İcmatse 2022, I hope in Turkish, inshallah.
Inshallah.
We will hold it physically and virtually together, and we host you all in Turkey, not only the scientific study or presentation, but also we will visit together the historical places and other activities such as barbecues, you know. Thank you very much again, all of you, dear chair.
Thank you very much, Mr. Ateş. Dear speaker and participants, it was great pleasure for us to welcome you to virtual meeting of the International Conference on Advanced Material Science, Engineering and High-Tech Device Applications. I hope you are all enjoyed the conference and presentations. I wish you a good weekend. I wish to meet you in the other conferences, as Mr. Ateş said. Best regards to all of you. Thank you very much again.
Thank you.
Thank you.
Bye.